Hello, this is Kevin Fisher. I am the sole developer behind this video game, Ludwig. I am doing a series of videos talking about the various elements in the game, the technical components. And this video I'd like to talk about the enemies and how I get them to move, their pathing, other various aspects about them. Let me go ahead and switch views here. Alrighty. So, how's about we take a look at one of the first enemies I implemented, which was the cowboy. So let's put him down. We're going to put him in a little wall so that he's not going to interact with us. I'll go ahead and put myself over here. Very good. I'll test. Now, this guy always just aims at where I'm standing, and he doesn't move at all. He just stays in one spot. This was the first enemy I implemented because I just kind of wanted to get something in the game to test. And what's interesting was that I found, even at this stage, it was actually kind of fun to fight him. Let me go ahead and switch back to the editor. And this time we're going to change things a little bit. Make some grass. Very good. So he shoots these little coffee beans at a consistent rate here, as you can see. Always aiming at where I'm standing. And then pay special attention to his sprite. As I pass the X coordinate here, he turns to face me. He doesn't necessarily have to aim up and down. I noticed that doesn't particularly matter too much. Just switching left and right is enough. Alright, let's return to the editor. Alright, let's go pull up the code for this guy. Alrighty. So, in my game, you might notice some of these annotations. PUB, or pub, that means I want to publish this entity so that I can find it in the editor. And then if I have a field that I want to change, like naked, I can publish that as well. And that will also show up in the editor. Alrighty. Give me 1 second to check something. Accessibility. Yeah, we'll disable nudity. There we go. Alrighty, so this should be fine now. If I make him naked. There you go. There he is. He is now a naked rat. And now he's got his clothes back on. All the enemies also have the ability to respawn. This is in the base entity, the base mob class, actually. And that means if you kill them, they'll keep coming back. And I implemented that because I found that there were areas in the game where the player could find a choke point and basically lead the enemies back and forth from that area and just kill them all from a safe distance. I wanted to have a challenge where you actually needed to navigate through the enemies. You had to figure out how to pass them. And there's one level in the game in particular that utilizes a lot of these guys, and it's one of the more intense parts of the game. But definitely one of the parts I'm very proud of. I like seeing people overcome that challenge. Anyways, let's take another look here. Let me also double check my recording here. Yeah. Alrighty. One of the interesting things I had to do when I was prototyping, the size of the enemy was a lot smaller, only 8 by 8. However, what I had found was that I really needed to increase the size of these things because, visually speaking, let me add a cast iron pan here. Visually speaking, it just doesn't work Like if I was standing here and I made that shot, in the old version I would have missed that. And I find that players don't find it very satisfying when they're not hitting enemies than they think they should, you know? They will literally see the sprite of the pan just like clip through, so it was important to exaggerate the sizes of the hitboxes. Which, by the way, let me hit F4 here. That turns me into my little a little box. This is when I was prototyping, everything was just boxes, just like this, and I essentially designed the game in this state where everything was boxes, you know, and later I applied graphics, and afterwards I started adjusting the sizes of certain things. You'll notice there is a shadow underneath this guy. The shadow is based on the hitbox, but it doesn't have to be. It's just by default, it's based on the hitbox. If I specify a specific shadow size, then that's what I'm going to get. So let me go back to the editor. Editor. One of the things that all the mobs can do is they can steal keys, but certain enemies, I just don't want to have that behavior, so I can disable it this way. There are levels, for instance, the sheep can steal keys. I think the spider can steal keys. At one point, the piranha could steal keys, but the piranha was kind of difficult to chase down, especially if it was traveling way out into the ocean. And if you killed it, then it could like just drop the key in the middle of the ocean where you can't get it. So I basically had to... That one was kind of forced. Anyways, this is the line that actually schedules our shooting routine. And basically what you see here is I kind of schedule it again at the end of this routine, basically. So it's like, okay, we're going to perform this action again in 1 second. But you'll also notice that it's inside an if statement like this. So one of the things we're first checking is like, hey, am I actually alive? Because the routine doesn't just stop when you kill the guy. When you kill the guy, this routine is still going to get fired. So we still need to check to see like if I'm actually in the level still, or if I've been removed or killed. Then we have these things called display only. This is how I kind of work with the editor. Some of these entities, all the entities are set to display mode right now. So that means, technically speaking, this is the coffee shooter entity. There's no separate like editor entity. Like it is him, but his display only has been set to true, which disables a lot of the logic, like shooting and other things. But it still has things like the animation system going, which I wonder if that's in this file or if it's in another one. I think it is. It's in Draw Animator. Check this out. So yeah, display only, right? So if we're display only, it's actually because display entities don't run their update routines, so this is kind of like a compensation for that. Like, okay, if we're display only and we're trying to draw the animator, can you please animate it? That way we can actually do things like this. And one of the reasons why I particularly enjoy using the monogame framework and versus say like Godot or Unity or something like that is because, let me select this guy and I can move him, right? Notice how he aims. That's because the logic that causes the sprite to flip back and forth is inside the animator, not necessarily the update loop. And I think that just makes the game a lot more charming and kind of like alive. It's as if these entities are actually standing here and kind of waiting for your direction to start, you know, doing their tasks. And I think that's kind of cool. I think that's kind of cool to be sitting here and kind of like looking at the level in this sort of living, breathing format versus, say, you know, Unity or Godot. I mean, no flack to them. They're incredibly capable engines, and you can totally program the logic that you want. I'm just saying that in monogame, you're kind of forced to come up with these solutions, and sometimes these things just emerge out of not necessity, what's the word I'm looking for? They just kind of emerge. It's emergent behaviors, and that's something I really like to take advantage of in my projects. So I think that's one of the reasons why I'm drawn to monogame and its capabilities. Um, and now let's see. I don't want this to transition to talking about level editors and things. We're talking about the shooters and the mobs and stuff, the enemy intelligence. Okay, so this was a pretty easy one to understand, right? He shoots at the guy, you know. He aims and he shoots. Let's see, anything interesting here? No. Okay, let's move on to the coffee chaser. This one's interesting because he actually has pathfinding, and you might expect like, oh, you know, pathfinding, that's got to add a lot of complexity to the entity, but actually in this case, not really. And I'm going to explain how. So let me make a connection here. Let's do it like this. So I'm going to move you here. We'll put some water here. We'll put this wall here. As I'm making this video, I'm wondering if I want to change the splashing sound effects because to me this kind of sounds like dropping something in a toilet, and it's a little bit weird now. It's a little bit awkward. I can't get that out of my head. Let's put this guy down here. So he's a chaser. He is going to chase me once I, let's see, where's the boot? There we go. So we're going to test now. So I have a boot. I can jump. It's going to help me avoid this guy. But yeah, he always takes the shortest path to myself. And let's just go kill him. That is done. It's actually not done through the path follower. That's kind of a red herring here, because what that does. Let me reset that. Return to editor and test again. Okay, so I have this guy. Okay, I'm gonna go over here. All right, you see how he's going back to where he spawned? That is what the path follower is for. It's to generate a path from an arbitrary location in the map to another arbitrary location. There is actually a different system when you're trying to path towards the player, because a lot of things are targeting the player, you know. So rather than like, you know, running an A-star algorithm like over and over and over again, like I would prefer to propagate the player's position through these cells, and it's just going to basically flood fill the map, you know, to all the cells that the player could access potentially from this cell, for instance, let's say. That's going to fill the map with some vectors. The enemy is going to read that map, and he's going to follow that to get to the player. So you end up getting a very, very intuitive... let's see, where are we at? Shoot. Can reach. Aha, here we go. Our reach grid. Interesting. Allied. Oh, yes. Okay. This is an interesting one because the coffee chasers can get allied. And that happens when... okay, we'll actually go into that a little bit later because that's a whole nother thing. But, right, can reach from world. I talked about propagating positions, right? Well, can reach from world looks kind of like this. It's about checking to see, like, hey, is this point inside our came from map? This is basically a Dijkstra grid. You can look up how Dijkstra would work, say like on Wikipedia or something like that, but it's very standard, and the only different things customizing that I'm doing here is I'm adding a valid neighbor like predicate, and that's used to cull things like water or walls, basically areas that the enemy can't get to. So there's more than one Dijkstra grid. Some of them are for things that can only travel on land, and other ones are for things that can only travel or prefer to travel through water, like the piranhas. And then there is yet another that travels on land and water, that one is used if you ally with if you ally with the rats, they will travel through the water and land to be your buddy and follow you wherever you go. Now let's see here. Let's see. Okay. Any shoots? Let's see. Faller, Velner, collided. All right. How about I talk a little bit about collisions here? That is. Gotta kill these guys. So, repelling, it's gonna take the entity, and these are the velocity movers are what makes these guys move smoothly over time. Ludwig moves one, like his movement is not like interpolated or smooth in any way. It's like, okay, if I press a button and hold that button down, he just moves in that direction at a constant speed. And if I hold two buttons down at the same time, he'll move in those two directions at once at that constant speed. He moves faster diagonally than he does in any of the cardinal directions, and that's intentional. I actually found that to be more satisfying for this game. Now, I'm going to go ahead and grab this boot. These guys, on the other hand, have a velocity mover, which is controlling... Whoa! Velocity mover, which is controlling their acceleration and speed and such. And their collisions repel them from each other if they happen to overlap. I'm dead. Alrighty, let's give up. And that will... originally, everything in the game would separate from each other. What that means is that if their bounding boxes overlapped each other, some math would be done to separate them from each other. It's a little bit complicated how this works. I'll try a little bit to explain. When you move an object, we're trying to create a bounding box that covers the distance that they've moved, so that and this is created by comparing their position with their last position being the position they were on the last frame. So we create this bounding box around them, which looks kind of like this. They're intersecting. If these boxes are intersecting each other, then there's some overlap. And we have to separate them now. That happens, let's see. Here's an example here. So, assuming they're both not immovable, then we're going to divide that overlap by 2 and place the objects, basically at the point where they hit each other, and kind of like, so they're now like kind of in the middle of that delta, that position change now, and their bounding boxes are kind of kissing each other. And I also swapped some flags here for their touching variable. This is a way to do some logic specifically based on what area of their box is touching what. I didn't really make much use of that, did I? I'm curious, actually. Let's see. I'm trying to run. I'm running a find usages right now because I'm kind of curious to see what I got. Except this is being weird. This is being really weird. Ryder, come on now. Thank you, okay. Yeah. Yeah, in this particular instance, nothing uses it. I copied it over from the Anodyne Sharp repo to kind of like get us started, or get a base for my collision logic. And nothing ended up using it. That sucks. Well, anyways. Forget about the touching thing. Forget I was talking about it. Let's see. We were talking about repelling. Let's see. Our chaser. I'm going to talk a little bit about how, as I was iterating through this project, I think the enemies were one aspect of the game that I think, since so many components of the game like kind of touch them, like, you know, the physics and animations, collisions, so many different things, it ended up being one of the aspects of the game that was susceptible to unintentional changes. I would work on a system, and suddenly the enemies wouldn't exactly behave the way they used to, you know, and I think that is one of the challenges, honestly, I think, where, say I'm designing a level, you know, based on the enemy's behavior, or intending or hoping that they behave a very specific way, and then they don't work that way anymore. That can be kind of annoying. Let me see if I can demonstrate what I kind of mean by that. Let me put some water here. Then if I go here, yeah, do you notice he walks all the way to the end of this? He walks all the way to the end here, and I've never really actually understood why he does that. But he does, and that just eventually started happening one day, and I'm like, you know what, I kind of like it, but I also, I'm not too, I don't mind if that behavior necessarily goes away down the road, but it is something that I'm kind of cognizant of, and I'm trying to think about how I can make the behaviors of these enemies a little bit more deterministic, so that I don't have to worry about, you know, if I mess with some certain systems, they're not going to. I can depend. Let's say that I can depend on certain behaviors behaving. Yeah, behaviors behaving correctly. Oh my goodness, I don't know what I'm trying to say here. But anyways, I'm wondering what else might be helpful to show. Let's check out the sheep, actually, because I think this was one of, I think, my more clever things that I did. I found, so remember I said I was propagating a position through this grid. One of the things I figured out that I could do, if I'm giving directions on how to get to the player, I can simultaneously provide instructions on how to get away from the player at the same time. So let me take this guy, get rid of him. Excuse me. Alright, so he's gone. Let's add a little sheep. Some grass. Alrighty. Now, I might want to change his running behavior, because right now he's got wandering enabled, so that he sometimes wanders, which makes it so that he's like, sometimes it looks like he's running away, other times it looks like he's like attacking me, which is fun. Let me come back here. Let's change his wandering. Retreat. Instead of wandering, you're going to go very fast. This is I set this up so that I could make him. There's a specific level where I have to try and nab a key from one of the sheep, but he moves super fast. So it's like, oh, how do I get to him, you know? I won't spoil exactly how you do it, but I think it was kind of a fun part of the game, and it kind of emerged while testing the enemy and like trying to find something that was kind of fun to do. So anyways, I'm sorry, did I fuck up? I might have fucked up. Okay, I returned to editor. Yeah, I didn't. Okay, are you actually set to very fast this time? That looks more right. Okay, cool. So, anyways, notice, yeah, I can stand on a specific spot, and whichever spot I stand on, that basically makes him run somewhere. Let's go ahead, come over here. I think, yeah, one of the things I found was that if I put any dead ends and he hits a dead end, he kind of just gets stuck there. So I just designed around that, and wherever I kind of want to make use of that retreating functionality, I typically design it like this so that there's no dead ends. Makes it a lot more, makes him move a lot more. So let's do that. So now he's running around. I can keep chasing him in all these different ways. Very satisfying. Because now he's like, oh, I want to hit him. No, but he keeps turning the corners. And it's funny because like it's not like they have any AI to specifically try and dodge my pan. It's more so I myself, the player, am moving, and as I move, that map that gives them the directions on how to avoid me gets updated and kind of gives the illusion that they're trying to avoid me, which I think is very interesting. Like if I can do something like this, where it's like, okay, I found a square where I can like shoot him now, and as a designer, I might be like, okay, let's put some walls there or something so that I can't do that, you know. So now it's like, okay, let's do that again. Right? I think it was this square or something. We go here. This is an example like where I'm actually pretty happy with the deterministic behavior here, because like if I stand on the square, he ends up at that square again. That's very helpful for me as a designer, and I can't hit him anymore. So kind of like with a little combination of the AI, a little bit of combination of design, it looks like he's smart, and he's like, aha, I'm behind a wall, and I don't have to run away from you because you can't hit me. And then I'm like, okay, well, I'm going to go try and get you now. And he's like, whoa, fuck. And now he starts going away again. So, yeah, I mean, like, you don't have to design really sophisticated AIs sometimes. You just kind of have to be kind of clever sometimes, you know? Okay, I think maybe I'll dig into the sheep now a little bit so you can see how he looks. But sheepish mob. Okay, yeah. Again, you see the veil mover. That's giving him that smooth movement that you see. I'm passing a speed and direction to the veil mover to control how that moves. And notice I'm using that Dijkstra grid. It's reach player on land. So if I go in the water, he's not concerned about me then. Let's see. Notice my retreat behavior controls how fast the sheep runs away from me. And notice, can retreat from world location. That kind of means like, hey, similar to the coffee guy who's chasing me, the sheep is checking that same grid. Like, oh, hey, is there a point in the map that indicates I can retreat from him? And that controls the speed. Like, okay, if I don't have to retreat, then I can be calm. That's all. Okay. Wandering, that's the interesting thing. So some enemies kind of wander haphazardly in weird ways. That's all done through just some oscillating sine waves, basically. So this wandering vector is controlled through here. Some cosines. Throwing in these guys. this is interesting because every time I respawn, all the people with this wandering component are going to have random wandering values, and I'm just not still 100% certain if maybe I want to change that and how that works. But as of right now,